Hey guys. All right, so this is the second part of graphing. And yesterday we looked at graphs like this, where we had an A value, we had a H value, and a K value. And today we're going to change it up a little bit. We're going to add in this B value. Okay. So it obviously affects my graph more, right? If I add a B value here. But I want to try to figure out, how is it affecting my graph? What is it doing? What is it doing to my slope? Because that's one thing that's changing, right? It's getting more narrow. And what is it doing to my vertex, and why is it doing those things? Okay, so that my vertex is moving and my slope is is changing here. So if we think back to when we were just looking at equations and identifying the transformations, we said that the absolute value of B, which is this number here that I'm adding, the absolute value of B caused a stretch, or a vertical stretch, or a horizontal stretch, or a horizontal compression, or a vertical compression, based on if it was bigger than 1 or between 0 and 1. So what does that affect? The stretch and the shrink, how is that affecting our graph? So here, if I take out this to here, well, the stretch and shrink is changing the slope. So yesterday we used the A value to help us find the slope. And now it's doing that again. So this value is going to change my slope again. So how is it changing it? Well, if I look at just with my A value, my slope, we looked at that and we decided yesterday, well, if my A value's here, that's going to be my slope. It's 2. So my slope here should be 2. So let's see. We got 2, 4, 0, 0. So I rise 4, I run 2. 4 divided by 2 is 2. So my slope is 2. So now let's add another value here. Okay, well, now I'm going from 0 to 4, so I'm rising 4 still, which makes sense because my K value is 4, but I'm only running 1. So now my slope is 4, okay? So my slope changed from 2 to 4, based on me changing my B value to 2. So what I'm doing here is I'm using the absolute value of A times the absolute value of B to get a new slope. Both of these things affect my slope. They affect the horizontal and vertical stretch or shrink, okay, or compression, or stretch or compression. So if I multiply them together, I can figure out what my new slope is. But it's also affecting my vertex. I'm going to graph a few things with you so we can see this better, but it's also affecting my vertex when I add this 2 or take this 2 out, when I change my B value here. So how is it affecting my vertex? Well, originally we can look at this and say the opposite of H and K is my vertex. So -2, 4 should be my vertex. Yes, that's my vertex. So how does it change when I put a 2 here? Well, change my X value. My Y value stays the same. My K isn't affected, but my X value is changed to -1. So if I think about my general form of this type of function, we would have A times the absolute value of B times X minus H plus K. So my general form, I have B times X minus H. Well, that's not what this function, I'm going to change this to G so we know I can reference it. So that's not what G of X looks like. It looks like BX plus some number. Well, if I were to distribute that B in my general function, then I would have A times the absolute value of BX minus, I have to distribute it to everything, BH plus K. So these two things are my general form. All I've done was distribute this B value into everything inside of my parentheses, inside my absolute values. And this looks more like this. I don't have parentheses in here, so it's not in my general form. I have this B value kind of distributed through. So I can think about this 2 ways. I can think about, well, I'm going to factor out? What can I factor out so that I can make it look like my general form? Well, I have a 2 in both places, so I'm going to go ahead and factor out a 2. If I take a 2 out of 2, that's going to leave me with 1. Now it looks like my general form. So my h value now is the opposite of 1, which is negative 1. And my k value is 4, so my vertex should be negative 1, 4. That's what my new k value is. We can also think about this as, well, my vertex, yesterday we said it was h, the opposite of h, comma k. Well, so now if I have this b value that I'm factoring out of h, then essentially when I factor, what I'm doing is I'm dividing. So I would have to actually take the value of h that I see and divide it by the value of b and then have k. So I can think about it like this. I can figure out my vertex by not factoring and just by saying, well, what's the opposite of h divided by my b value? And then I get my k value, and that's my vertex. Or I can go ahead and factor out, and what's my what is the h value I see, the opposite of that, and my k. Okay? So let's look at some examples. Let me get my iPad on here. Okay. So number 1 here. I'll zoom this in a little bit. All right, so number 1. Remember, we have this idea that we can factor things out. So then this is just like the problem we just did. So this would actually be 2x plus 1 inside my absolute values. So my vertex would be the opposite of the h, my new h value, which is negative 1, and my k value is 4. Or we could also look at this and say, well, my vertex is the opposite of h divided by b, comma k. So the opposite of h of my, let me change my color here. So here I'm looking at this, okay? So the opposite of h would be negative 2 over my b value is 2, comma 4. Well, if I simplified this, then that's actually negative 2 divided by 2 is negative 1, comma 4. So I can think about this either way. I can go ahead and factor and immediately see this value, or I can just look at what I'm given and come up with my vertex. So I'm going to plot my vertex just like normal. My vertex is negative 1, 4, so I'm going to have a point here. I see a negative sign right here, so that means I'm going to open down. And now I want to figure out, well, what's my new slope? Because this b value affects my slope. So my slope is going to be the absolute value of a times b. Absolute value of a times b. So here, a is negative 2, b is positive 2. So the absolute value of negative 2 times 2 is 4, because negative 2 times 2 is negative 4, but I'm taking absolute value, so it's positive 4. So that means my slope, that negative sign tells me I'm going to open down, and my slope is going to be 4 over 1. So I'm going to go down 4 over 1, down 4 over 1, and I'm going to do this on both sides because we're symmetrical. And I'm going to go ahead and draw those lines without drawing any more points. Okay. So for now, I'm just going to go ahead and use this formula to find my b value. So let me do another one with you. Let's see, that was negative. Let's do number 4 together. And then I'll let you guys do the rest of this. If you have questions, please reach out to me. Okay, so number 4, I can use my additive identity to say, well, I can add a 0 here. So that means my negative h over b, comma k, my vertex is going to be, I'm going to use my h and b. So it's going to be the opposite of h, which is positive 6, over my b value, which is negative 3, and my k value is 0. Well, 6 divided by negative 3 is negative 2, 0. So I'm going to have negative 2, 0. I'm going to have my vertex here. Then my slope is the absolute value of a times b. So I would have the absolute value of 3 times negative 3, which is going to be positive 9. So this is opening, I have a plus sign here. It's positive, so this is going to open up. So I'm going to go up 9 over 1. Oops, that's 8. I'm going to go up 9 over 1, up 9 over 1, and here's my graph. This is not perfectly drawn, but it's close enough. Okay, so I want you guys to work through the rest of these, upload pictures so I can review them. If you have any questions, please let me know. I'm more than happy to answer them. All right, have a good day.